What if your software could just build itself? Sounds like something straight out of a sci-fi movie, right? Well, some new research is making it a reality. Today on The Explainer, we're going to break down exactly how. Let's kick things off with this powerful quote from NVIDIA's CEO, because it really sets the stage perfectly. We're not just talking about some minor update here. We're looking at a fundamental, ground-up shift in how technology gets made and how it works. So, to really get a handle on where we're going, we first have to be clear about where we are right now. Today, AI is an absolutely incredible tool for software developers, but it's still just that, a tool that a human has to use. Think about today's AI as an amazing co-pilot. It can help you code, find bugs, even suggest better ways to do things. But at the end of the day, you, the human, are still the pilot making the final calls, steering the plane. The research we're digging into today asks a really radical question. What happens when the AI moves from the co-pilot seat into the pilot seat?
And this brings us right to the core question posed by the researchers, a question that could honestly change everything we think we know about making software.
So what if we just flipped the script? Instead of using AI to help us write the code, what if the AI was the code? What if software could be this living, breathing thing that understands what you need and just evolves on its own to do it? And the answer to that question is this concept right here. Imagine you open up a program that starts out super basic, or maybe it can't do anything at all. But then, just by talking to it, telling it what you want in plain English, it starts to build itself into a highly specialized tool tailored perfectly for you. Now, I know this is starting to sound a lot like magic, but the researchers actually built a working prototype. And it's not some single giant AI brain, it's a really clever system of different agents all working together. So let's pop the hood and see how it works. Okay, so how does this thing actually tick? Well, the whole system is set up like a tiny, fully automated software company. First, you've got the leader. Think of this as the project manager. It's the one that talks to you, figures out what you want, and makes the big decisions. Then there's the code generator. That's your star developer, cranking out all the new code. The code validator is your quality assurance team, testing everything to make sure it's not going to break. And finally, the data manager is kind of like the company librarian, keeping all the code and data neat and organized. So, that's the theory. But here's the billion-dollar question. Does it actually work in the real world? The researchers didn't just write a paper. They put their prototype to the test in a bunch of different scenarios to see if it could really learn and grow on its own. Let's start with a really simple, relatable task. A user asks the software for a weather forecast. Now here's the key. At the beginning of this test, the software has absolutely zero ability to check the weather. It doesn't even know what that means. The test begins pretty simply. A user asks for the weather in Beijing, then a little later they make a similar request, but this time for London. Now this might seem trivial, but how the system handles that second request is what shows its true power. So for that first request about Beijing, the leader agent realized, uh-oh, I don't have a tool for this. So it kicked that little internal software company into high gear. The code generator wrote a brand new Python function to grab data from a public weather service, the validator tested it, and the data manager saved it. Just like that, the system literally built itself a new skill from scratch. But this is where it gets really interesting. When the user asked for the weather in London, the system didn't build anything new at all. The leader was smart enough to recognize, hey, I know how to do weather stuff now. It just grabbed the tool it had already created, swapped out Beijing for London, and got the answer. This proves it's not just building things blindly, it's learning and becoming more and more efficient over time. And that weather example, that was just the warm-up. As you can see here, the researchers threw all kinds of challenges at it. It learned to manage local files on a computer, basically building its own little expense tracker. It learned how to interact with the web, downloading resources from GitHub. It even built a text formatting tool from scratch. In every single case, the software didn't just complete the task, it evolved, adding a permanent new skill to its toolkit.
This prototype is an absolutely incredible first step, a fantastic proof of concept. But the researchers also looked ahead, and they outlined a pretty bold vision for where this technology is headed and what it's going to take to get there.
So, where do we go from here? Well, the roadmap lays out the next huge hurdles. First, scaling. Can we go from these simple tools to massive, complex applications? Next, we need benchmarks, standardized tests so we can actually measure and compare how good these systems are. And of course, reliability is crucial. We have to be able to trust the code these AIs are writing. But the ultimate goal, the real moonshot, is what they call full self-evolution.
Software that's so smart it doesn't even wait for you to ask. It proactively figures out its own weaknesses and just proposes new features to build for itself.
This all leaves us with one final really provocative thought. As this technology gets more powerful and moves out of the research lab and into our lives, the only real limit to what our software can do might just be our own imagination. So what would you build?